Well, hopefully you had fun with that last extra long homework assignments. And you've learned that if you have any log base a of x equals r, that's just the same thing as saying a to the r equals x, right? And most of the time we've been changing these to this exponential notation in order to solve them. So today what we're going to do is we're going to talk about what happens when you don't have a base. So say for example you have just log base x equals r. You'll see that there's no base given there. This is called the natural log, or the log where a log of base 10. Okay? So anytime if there is no base, you simply assume a 10. So 10 is the base if you don't have one. And the good news about that is that that's what your calculator does as well. It always assumes that you're talking about base 10. So this, kids, is the first and only time probably where you're going to be plugging a bunch of numbers into a calculator and just doing the math that way. All right? Now, it doesn't really matter what calculator you use as long as it has a logarithm button. Even the one on your phone, right? Turn it sideways and you'll see that it has a logarithm button. But it's up to you to be able to know the keystrokes for using it. They tell you how on the TI-84 Plus, when you're just doing the Help Me Solve This or review an example on, or the video on the Help Me Solve This or review an example. But you don't want to, most of you probably don't have a graphing calculator to use, but you can use any calculator that does have a log button. That log automatically assumes a base 10. Now before we start doing that though, we're just going to evaluate some of these and get you used to seeing that where there's no base, you assume a 10. So let's just go straight to the homework. So we have log base 10 to the negative 8. All right? So what's missing here, if you have log of 10 to the negative 8, is you don't have any number here as a base. There's no little number floating underneath that g. And you have to in order to be able to evaluate one of these if it gives you all these pieces. So you need to just remember that any time there is no base, you assume that base to be a 10. Okay? So what number, what exponent would you put on 10 to get 10 to the negative 8? Right? Well, you can solve this one by setting it up as an exponent. Base raised to the exponent, right, equals the number to some power. And the power is simply going to be negative 8. Okay, so log base 10 to the negative 8, in other words, equals something, we don't know what. It's just going to be the exponent as your answer. Don't be creative with these. What they're really wanting you to see is just that negative 10. Let's look at another one so you can see. Because we already had all the pieces of that one, right? There was not any unknown part of that, so there was nothing to solve. Let's look at this next one. So the next one, we have log, no base, of 0.1. Okay? Well, that means we have a base of 10. If you don't see a base there, you assume it to be 10, right? So if you want to find the exact value of this base, oops, went away. So we just have to make sure that we put some power on there, to make that some power of 10, right? So some power there. Well, if you're going to put an exponent on a 10 to make it into a 0.1, then you've made it smaller, but the number has stayed the same. So that's 1/10, right? 0.1 is the same as saying 1 over 10. The only way to get a fraction is to have a negative, and if you didn't change the number, then the number part of the exponent is negative 1. So log base 10 of 0.1, okay, is negative 1. So what exponent would be there to turn that into that? Okay? All right, let's look at some more. Okay, and now is where we get into just simply using the calculator. So I'm going to show you these with the answers already there so that you can see, because I can't really show you what's going to happen because I don't have your calculator. So you're going to use whatever calculator you have. But if you're finding, and it'll tell you, use the calculator to find the common logarithm. Common logarithm means that it's base 10. So you're just going to push in log of 17. Some of those you'll push in log, it'll open up some parentheses, you'll put in the 17. Some of them you'll push in 17 and then you'll push log. It just depends on your particular calculator. Okay? So, however you do it, it's going to give you some long strung out decimal. But you pay attention to these directions because they want you to round it to 4 decimal places. And that's round, not just cut things off, right? So for example, the log of base 17, if you put that in your calculator, you're going to get 1.230448921, depending on how many places your calculator will go to. Well, this means we want to round to the 4 decimal places. So we look at that 4. Remember, if it's 5 or bigger, it would add 1 to that 4. But this time it's less than 5, so it's just going to drop that stuff off. So no math really involved here. You're just going to push in numbers into the calculator, but you better make sure that you're rounding to the right decimal place. That's about the only problem you could have here. Okay? Find the common logarithm. That means it's a log base 10, so just use your calculator. Notice this one came out to be a negative, and you rounded to 4 decimal places. Be very, very careful. And so all of these, make sure you put that into the calculator as a fraction, right? You have to use parentheses. Now, or you could do it as 2 separate decimals, and then subtract them, because that is a quotient. So you could use the quotient rule too, depending on your calculator. Make sure that though you do not round as you go, you round your answer. So, for example, if I did this particular one, and I did log of 526 minus log of 350, do each one, and then use those decimals to do the subtraction. Do not round while you're working, but when you're finished. So for example, this one would be 2.720985744 minus the log of 350 would be log 350, 2.544068044. Subtract those two. Then I get 0.1769177. Okay? I want it rounded to 4 decimal places, so that's 4 decimal places. The number after the 9 is a 1, so all that rest of that stuff is just going to round off. So you can do it as a subtraction, right? Because you're taking a logarithm of the top, a logarithm of the bottom. Now, you could also simply divide those two numbers first and then take a logarithm of that, And as long as you don't round before you take the logarithm, you will probably be okay as well. Now, if you have your calculator set to round it for something weird, you're going to need to reset it. Make sure you don't have it rounding to 3 decimal places or something like that. Okay, find the value. Now these two, find the logarithm of that log, and obviously add them together, right? So just find the log of each one and add them together. We did that in the last homework. Here, log base 2 of 9, use the change of base theorem to find the logarithm. So this is the only other thing that we haven't talked about in this section, so let's talk about the change of base theorem. It is incredibly easy. Our calculator can't do log base 2. It's set up to do log base 10, the natural or common logarithm. So what we have to do is change this logarithm into log base 10. And it turns out that there's a simple pattern for that, and it's called the change of base. So what you're going to do is you're going to make a ratio, in other words, a fraction. Okay? Remember that you have log base A of x, right? Well, for change of base, all you're going to do is simply take the log of the x over log of the a. Okay? Okay, so any one that you have, and you could actually change it to any base, but of course since your calculator does log base 10, that's what we want to use, so just log of 9 divided by log of 2. And that will give you what this answer would be. Okay? Now, again, depending on how sophisticated your calculator is, you could find this log, then you could find this log, or you could put them in as log of 9 divided by, right, using the division key, log of 2. Depends on the calculator that you're using. Make sure, though, we want that final answer rounded to 4 decimal places as needed. Okay? And so this is called the change of base. Just put one over the other. Couldn't be easier. And that is what the rest of them are going to be. Change of base. So log of 9 of 0.77. So that means you would simply put the quantity, log of the quantity, over the log of your original base. And then just use your calculator to do the math, right? And it gives you the answer rounded to 4 decimal places. You will like this section as long as you remember which one you have to put where, right? So 5 over 1/4, and again, depending on your calculator, you could do that as 1/4, or you could do it as the log of 5 over, don't put it as an exponent looking thing like that, is it? 1/4, or you could change that into 0.25, because it does come out even, as long as you don't have something there that you round. You wouldn't be able to do that if it was 1/3, but I don't think they would be that mean to you. Okay, and then just take the log of both. Right, change of base to find the logarithm. This time, the base is pi. That changes nothing, because every calculator you have, every scientific calculator you have, is going to have a pi key somewhere. So you'll take the log of 43 over the log of pi. That is a number. Your calculator will recognize it. So just take each log. There's your answer, rounded to 4 decimal places. Right? So don't freak out because they use that symbol pi. Doesn't change the process one bit. Now this one we have a square root. Your calculator can do a square root. That's not a problem. So that would just become, using change of base, it's just going to become the log of 20 over the log of the square root of 11. Remember, you're going to get some decimals when you do that. Do not round until you get to the final answer. It tells you right there on the page, and it will on the test as well, so make sure you don't. Okay? Now, if this is not the easiest homework we've done, I don't know what is. All right. Thanks. See you next time.